Hello and welcome. My name is Maciej Świechowski from QED Software, and I will be talking about selecting specific diverse pairs for the crossover. One of our upcoming projects will concern developing rule-based logic programs. Such programs can be used as explanations and summaries of complex models or processes. As a step towards the goal shown in the previous slide, we do something simpler. The problem of choice is the evolutionary decision tree induction. A decision tree can be considered a subset of a rule-based logic program. They are structurally similar. We use equality conditions with up to 4 distinct results and inequality conditions. In this research, 5 methods, with 4 of them being original, are presented. Please note that this work concerns methods for choosing individuals for the crossover. It's like a dating algorithm. First, let us show how the actual crossover operation is performed. It is the same for all crossover selection methods. The trees encoded by the individuals are split into left and right parts. The left part of the first phenotype is merged with the right part of the second one. The root of the fitter individual becomes the new root. We also experimented with a fixed or a random choice for the new root. Please note that there were a few tricky implementation details here, but we omitted them. The general idea is very simple. For a fair comparison, the same number of individuals is recombined in each method. They only differ by the way they perform selection and pairing for the crossover. In novel methods, we introduce a so-called complementary fitness, which will be shown on the next slide. It is calculated for pairs of individuals. We combine pairs AB and BA that maximize such complementary fitness. In the standard method, we use only the regular fitness, which is the accuracy of the encoded decision tree on the training dataset. The hybrid methods combine a respective novel method with the standard selection. Here, half of the individuals is chosen according to the novel formula, and the other half in the standard way. Here we show how complementary fitness is computed. In the 2 variants, it works as follows. Depending on the value encoded in the decision tree root, each record in the training dataset either falls to the left or the right subtree. We calculate the fitness value, which is the classification accuracy as we defined it, for both subtrees individually. The complementary fitness is the upper bound of what the fitness could be for the merged subtrees. In the N variant, we consider both decision trees of the candidate individuals as a special kind of an ensemble model. Let's assume that there is an oracle that knows which decision tree is better in a given state for classification. In other words, the ensemble model returns the correct decision if either of these trees returns the correct decision. The complementary fitness is the accuracy of such a special model. All right, let's get to the results. The method were tested in 8 experimental setups. They varied with regard to the depth of the tree, which stems from the number of independent variables, the population size, the portion of the population that undergoes the crossover, and the number of elements in the training set that were used to compute the fitness value. Of the 5 presented methods, Hybrid 2 achieved the best results. In 6 out of 8 cases, it was significantly the best. The Hybrid N and the standard methods came second. Interestingly, the pure novel method, without any mixing, achieved the worst results. Okay, let's conclude now. We've introduced complementary fitness as a measure to predict how good the potential offspring can be. This approach is useful for scenarios where the final fitness value can be calculated as a sum or other type of aggregation of partial values. Hybridization of our novel methods with a method that uses standard fitness achieved the best performance. In future work, we plan to include more sophisticated problems as well as more ways of determining complementary fitness. Thank you for your attention.